Hi, and welcome to the Module 14 quiz, are ready to go on, the textbook version of the quiz. And we're going to get started with number one. Uh, you got to write these fractions as a decimal, and each decimal is a fraction. So you just divide. 7 divided by 20, that's 0.35. 1.27, remember the 27 goes over 99, and that would be, what this would be is 1 and 27 over 99, which, oh, that can be simplified to, you can divide them both by 3. You can divide them both by 9, actually. Ooh, let's see. If I divide them both by 9, that would be 3 over, yeah, 1 and 3 and 11s, and then that becomes, as an improper fraction, 14 over 11. And then 1 and 7 eighths, that is, yeah, the 1 that 1 goes right there, and then you divide the 7/8, which is 0.875. Solve for x. Well, what number times itself is 81? That's 9, and also negative 9. And so you would have 9 and negative 9. What number times itself is 343? I think that's 7. I think it's 7. And it's 7. And then what number times itself is 1 over 100? Well, I think 1/10 times 1/10 is 1/100th. And it's positive or negative. Yeah. And a square patio has an area of 200 square feet. How long is each side of the patio to the nearest tenth? And what we need to do is take the square root of 200. I know that the square root of 196 is 14 because 14 times 14 is 196. So I'm calling this like 14.1 or 14.01 or something like that. And so 14.1 did it. And write all the names that apply to each number. Well, this is going to be 121. The square root of 121 is 11, and 121 divided by 11 is 11. That's a whole number, and it's a whole number, integer, rational, and real. So it'd be all of them. Yeah. And then we have pi divided by 2. Well, pi alone is an irrational number, and it's irrational and it's real. All right. Tell whether the statement all integers are rational numbers is true or false. Let's see. All integers are rational numbers. Yeah, they are, because they're part of the whole schematic. And I believe we would have, let's see. And so what we would have is, of course, this. Yeah, the integers can be written as a quotient of two integers. So, yeah, integers, like, for example, um, -3 is an integer, and that's -3 over 1, and that's what a rational number is. It's a fraction of integers, or you can have 8. 8 is 8 over 1, and there you go. It's a quotient of integers, basically a fraction. Okay, next we are figuring out which one's bigger. We're ordering those real numbers, and well, this one, I mean, you start with 3 here and you start with 8 there, and this one's going to be bigger easily. So it's to the right. And then this one, we're starting with, this is too easy. You start with 5 versus starting with 11. This one's going to be way bigger. And we have that one there. See how fast that becomes. The square root of 99, boy, that's almost 100. So that would be like, I'm sorry, yeah, 99 is almost 100, which is almost 10. So that's like 9.9. pi squared. Oh, okay, so this is 9.88. Okay. Oh, I made a small mistake on this. This is actually like about 9.9. And 3.14 times 3.14, I honestly don't know what that is. 3.3 times 3 is 9. 3.1. So I'll just do 3.1 times 3.1 to get an approximation. 1, 3, 3, 9, 9.61. Okay, I'm calling pi squared the smallest, I think, according to what I did. So, well, let's look at the order. Pi squared, smallest. Okay, because I'm calling that about 9.61, and then 9.8. Yep, and then and then square root of 99. Yeah, because not that's if I look at this here, 9.88 versus 9.90, you're looking at 90 compared to 88. That's why this one's the larger one. Okay, and number 14, square root of 1 over, so this ends up being 1/5, right? Because the square root of 1 is 1 and the square root of 25 is 5. And then this is 1/4, and then this is 2/9. And you know what? Probably I should have just kept that as a decimal. That would be easier to compare. So this would be 0.22, this is 0.25, and this is 0.20. So that looks like this one is the smallest, this one is the next biggest, and this is the biggest. And we have this. Yeah, that's what I said. Good. And then we have this one. How are real numbers used to describe real world situations? Well, here is a possible answer. Real numbers, such as the rational number 1/4, can be described to use amounts used in cooking. There you go. Down and dirty, quick, Module 14, ready to go on Module quiz. I hope this has been helpful. Thanks for watching.